Hi everyone. Okay, today we are learning about rational exponents, so exponents that are fractions. Our learning goals are to learn to evaluate numeric exponential expressions that contain rational exponents, to learning to link the link between rational exponents and roots, and we're learning the meaning of a rational exponent of the form m over n. Okay, so consider 25 to the exponent 1/2. So that 1/2 is an exponent, and we're gonna just talk about what does that mean. So I'm gonna start off with something we do know, and that is that the square root of 25 is equal to 5. And we know that that's because 5 squared is equal to 25. And we know that square and square root are inverse operations. So when you do the same thing to both sides of an equation, that is keeping it balanced. So what I'm going to do is I'm going to put both sides of this equation to the exponent of 1/2. And remember, we're trying to figure out what's the meaning of 25 to the 1/2. What does it mean? And then keeping in mind that the square root of 25 is equal to 5 because 5 squared is 25. So now we have a power to an exponent, and we know from the rules that we learned last week that when we have a power to an exponent, we keep the base the same and we multiply the exponent. So we're doing 2 multiplied by 1/2. And then on this side, we're just going to leave it as 25 to the 1/2. And then 2 times 1/2 is 1, so we get that 5 to the power of 1 is 25 to the 1/2. So we've shown that 5 is equal to the square root of 25. And we've also showed that 5 is equal to 25 to the 1/2. And if we put those together, we can say that the square root of 25 is equal to 25 to the exponent 1/2. So the exponent 1/2 means the square root. So the exponent 1/2 means square root. Now, let's think a little bit further. We've also learned over the years the third root of 64 is equal to 4. And the reason for that is because 4 to the power of 3, which is 4 times 4 times 4, is in fact 64. So, following a similar logic, when we do the same thing to both sides of an equation, we keep the equality the same. So I'm going to take both sides to the exponent of 1/3. And then doing the power to an exponent, I'm going to keep the base of 4 and multiply the exponents 3 times 1/3. And then 3 times 1/3 is 1. And again, in the same way, the third root of 64 is equal to 4, but 4 is also equal to 64 to the power of 1/3. So the third root of 64 is equal to 64 to the power of 1/3. So this is what we call radical form. The square root symbol is called the radical symbol, which we learned when we were doing quadratics. And this is called exponential form. But they mean the same thing. So when you're looking at this, you're thinking the third root of 64, or what number multiplies by itself 3 times to give you 64, and we know that that's 4. And then when we're looking at this, we should say 64 to the power of 1/3 again, that means the third root of 64, which means what number multiplies by itself 3 times to give me 64. Okay, so we've got the radical form and the exponential form. All right, so moving on. So I've kind of summarized those ideas in a chart here. So the meaning of the exponent 1 over n. So x to the power of 1 over n. Now remember, this is an exponent, so make it look like an exponent. It should be smaller and above, is equal to the nth root of x. Okay, the nth root of x. So the thinking is, what number multiplies by itself n times? So this little n tells you how many times. And then if we look back here, square root doesn't have a little number in here. Because we use it so often, we don't write that little 2 in. But it really means what number multiplies by itself twice to give you 25. And it's 5. 5 times 5 is 25. That's the number that multiplies by itself twice to give you 25. Okay? So the thinking is, what number multiplies by itself n times to give you x, the number under the radical sign? Okay, so examples. 81 to the 1/2 means the square root of 81. So that little 2 we don't need to write in because square root is the most common one. But we should be thinking, what number multiplies by itself twice to give me 81? And that's 9, and that's because 9 times 9 is 81. Similarly, 64 to the 1/3 is the third root of 64. And it equals 4 because 4 to the third is 64. Okay, so another way of saying 4 times 4 times 4 is 64 is by saying 4 to the third is 64. 32 to the 1/5 can be written as the fifth root of 32. And it equals 2 because 2 to the power of 5 is equal to 32. Or the number that multiplies by itself 5 times to give you 32 is 2. Okay? So our question is think and evaluate. So I want you to use your calculator as little as possible because it's going to help you a lot next year in grade 12 when you learn about logarithms. So the more that you can do these kind of mentally, even if it takes you a while at first, you're going to get to know things. For instance, you're going to get to know that 4 to the third is 64, so the third root of 64 is 4. And those numbers are going to become common. It may take a while at first, and you may want to use your calculator as backup or proof. So when you see 27 to the 1/3, you want to say, okay, well, I know that means it's the third root of 27. So rather than immediately going to your calculator, you want to ask yourself, what number multiplies by itself 3 times to give you 27? So you might think, well, is it 2? 2 to the power of 3 is 8. No. And then the next one you might go to is 3. Is 3 to the power of 3 27? Well, maybe you know it is. Maybe you don't know. So you might try 3 to the power of 3. Oh, that is 27. So the third root of 27 must be 3. Okay? I want you to do that thinking rather than just finding the button on your calculator. So it depends on your calculator. You might have an x square root of y button. You might have I have a x the root button, okay? There are calculator ways to do it, and I will go over them, but what I really want to start off with is just trying to think them through. So again, 49 to the exponent of 1/2 we know is the square root of 49, and without a calculator, most of you know that that's 7. 16 to the 1/4, so that's going to be the fourth root. So that 4 is like a little number, like an exponent, but it goes in the little corner of the root of the radical symbol or the root symbol. So the fourth root of 16. So that your thinking is, what number multiplies by itself 4 times to give you 16? So you're kind of thinking to yourself, some number to the fourth must equal 16. And the first one you would try is 2, and it turns out that that's true. 2 to the fourth is 16. So the fourth root of 16 is 2. 1,000 to the exponent 1/3 is the third root of 1,000. And again, the thinking is there's going to be some number to the power of 3 that equals 1,000. What number is that? And a lot of you will know that that's 10. Okay. 16 over 25, all because we're in brackets, to the power of a half. So I would want you to realize that you can use the exponent rule where the exponent applies to the numerator as well as the denominator. And then the thinking of 16 to the 1/2 means the square root of 16. 25 to the 1/2 means the square root of 25. And then knowing that the square root of 16 is 4 and the square root of 25 is 5. And now we've got a question written in radical form, sorry. So the third root of 343. So we're thinking again, there's got to be some number to the power of 3 that equals 343. Okay, and you may not know that one, so you may take you a while to try it. You might try 5 to the third. Oh, that's 125. 6 to the third, 216, 7 to the third, 343. So the answer would be 7. And then again, some of you may be wondering how to type that into your calculator. So there's a few ways, like it depends on your calculator. So if you have that button. So for me, I have that button. So I'm going to do 343 and then shift that button. Oh no, sorry, my calculator's the other way. So I'm going to do the third root and then shift. And then it gives me the third root of 343 equals 7. Okay. Some of you might have an X root Y button, and you'll have to figure out whether you write 3 and then that button and then 343, or 343 and then that button and then 3. But you know the answer that you want to get is 7. So play with your calculator and make sure that you know how to do that. 32 to the negative 1/5. So the first thing we want to do is address the negative exponent. So we're still going to use our negative exponent rule. So we're going to go 1 over 32 to the positive 1/5. And try to make that 1/5 look like an exponent. I know it's hard because it's a fraction. And then we'll write it in radical form. So that's going to be 1 over the 5th root of 32, which is, don't forget about the numerator, 1 over. So then I'm thinking, what number multiplies by itself 5 times to give me 32? That's 2. So 32 to the negative 1/5 is a half. So then I've got another one that's already in radical form. So the third root of 64 divided by the 4th root of 625. So again, third root of 64 means what number to the power of 3 is equal to 64? And you can try them, but you'll figure out that 4 to the power of 3 is 64. And then this one that you're asking yourself, what number to the power of 4 is equal to 625? And that's 5. 5 to the power of 4 is 625. I. Okay, so now we have a fraction to a negative exponent. So we have a rule for that, where if we flip the fraction, the exponent becomes positive. And then from the E question up here, we know that that exponent applies to the numerator as well as the denominator. And then we know that exponent of 1/3 means third root. And then we know third root of 8 means what number multiplies by itself 3 times to give me 8? That number is 2, because 2 times 2 times 2 is 8. What number multiplies by itself 3 times to give me 27? That number is 3. So that means that 27 over 8 to the power of negative 1/3 is 2/3. Negative 125 to the 1/3. So first, let's write it in radical form. So the third root of negative 125. So this is interesting because we know that we can't take the square root of a negative number. Okay, so we get an error. You can't take the square root of negative 25 because Negative 5 times negative 5 is positive 25, and negative 5 or positive 5 times positive 5 is positive 25. So there's no number that multiplies by itself twice to give you negative 25. So that's why you can't take the square root of a negative number. But is there a number that multiplies by itself 3 times to give you negative 125? And the answer is negative 5. So if you think about it, negative 5 times negative 5 times negative 5 gives you negative 125. Oops, move it over so you can see that. So negative 5 times negative 5 is positive 25 times another negative 5 gives you negative 125. So the third root of negative 125 is negative 5. Okay, negative 8 to the 1/3. So we know we can write that. And I'm looking at this as a multiplying question. I don't have the same base here, so I'm going to have to do each of these differently. So third root of negative 8, I know I can write in radical form. And that's times, I'm going to deal with the negative exponent first, 1 over negative 32, and I'm keeping that in brackets because the base is negative 32 to the exponent 1/5. And then, so third root of negative 8 means what number multiplies by itself 3 times to give me negative 8, and that number is negative 2 times, and then I can rewrite this in radical form, the denominator, as the 5th root of negative 32. Times, don't forget the 1 over. So in the bottom here, it's saying what number multiplies by itself 5 times to give me negative 32, and that's negative 2. And negative 2 over 1 times 1 over negative 2 is negative 2 over negative 2, which is positive 1. And then L1 over the third root of negative 1,000. So 1 over what number multiplies by itself 3 times to give me negative 1,000? That's negative 10. But that would probably be written in the back of the book as negative 1/10. Usually we don't leave the negative sign in the denominator. Okay, so moving on. So evaluate 27 to the 1/3 squared. So I'm going to look at this in 2 ways because it's going to help us with what we're going to be learning next. So first of all, let's look at it as 27 to the 1/3 squared. So we'll do the inside the brackets first. Okay, so if we do that, we would know that would be third root of 27 all squared. And the third root of 27 is what number multiplies by itself 3 times to give you 27, and that number is 3, but we're still squaring it, which gives us 9. Now, if we look at this question in another way, by using exponent rules, we have a power to another exponent. And that says we keep the base the same, 27, and we multiply the exponents. So if you multiply 1/3 and 2, you get 2/3. So 27 to the 2/3 must, these two things have to be the same. So when you look at an exponent of the form m over n, you can see with what we did here, the n number represents the root and the m number represents the exponent. So if you saw 27 to the 2/3, what I would want you to think of is, okay, I can write that as so the denominator of the fraction exponent tells you the root. The third root of 27 to the exponent, top number of the fractional exponent tells you the exponent. And then again, third root of 27 is 3, squared is 9. So that's what's in the next box here, the rational exponent rule. So if you have x to the m over n, it means the nth root of x to the all to the exponent m. So the n in the fractional exponent is the root, or the denominator is the root. The numerator is the exponent. And as a rule of thumb, evaluate the root first and the exponent second. And then there's another one we use less often, but you should also know that we can also say it's the nth root of x to the m. We don't usually use that in evaluating, but in simplifying, sometimes we could do it that way. All right, so again, when you have x to the m over n tells you the root, the denominator gives you the root, and the numerator is the exponent. So think and evaluate no decimal answers. So 125 to the 2/3, so we're going to think of that as the bottom number is the root, so the third root of 125 squared. Third root of 125 means what number multiplies by itself 3 times to give you 125? That's 5 squared is 25, because 5 times 5 is 25. 32 to the 3/5, so we want to do the fifth root of 32 cubed. The fifth root of 32 is 2, but we're still cubing it. 2 cubed is 8. 81 to the negative 3/4. So first let's deal with the negative exponent. So 1 over 81 to the positive 3/4. 1 over, so it's going to be the fourth root of 81 cubed, which is 1 over the fourth root of 81. That means what number multiplies by itself 4 times to give me 81, and that number is 3 cubed, which is 1/27. A common mistake people make in this one is they get so focused on evaluating the denominator that they forget that the numerator is 1, so just be careful with that. And this one, again, here the exponent was negative, and that's why we use the exponent rule 1 over. Here, though, the base is negative, so that doesn't affect the exponent. So this is going to be the third root of negative 27 all to the 4th power. So again, we can take the third root of a negative number. So what number multiplies by itself 3 times to give you negative 27? That's negative 3. The base then that we want to put this exponent to is negative 3, so we need to put the negative 3 in brackets to the 4th. So that means you're multiplying negative 3 by itself 4 times, which means you'll get a positive answer, and that's positive 81. Fraction to a negative exponent is what I see first. So the first thing we want to do is flip the fraction, and then the exponent becomes positive. Notice the exponent becomes positive. It doesn't flip or anything. Okay, we flipped the base and the exponent became positive. So now we want to apply that exponent to the numerator and to the denominator. And some of you may be able to go to this next step right from here, and that's fine. So that would be saying third root of 8 squared over third root of 125 squared. So the third root of 8 is 2 squared. The third root of 125 is 5 squared, which is 4 over 25. Okay, notice I'm not using a calculator. I'm trying to think it through. If you are using a calculator, have it to be double checking things like, is 2 to the third 8, which means that the third root of 8 is 2. okay? The better you get at recognizing these things, the easier logarithms will be for you in grade 12. So we've got a negative exponent, so I'm going to do 1 over the 4th root of 16 to the positive 5. Evaluate the root first, so the 4th root of 16 is 2 to the positive 5, so it's 1 over 32. G looks tricky, but if you recognize, it still is going to be a little bit more complicated than some of the others, but I want you to recognize that we're dividing powers with the same base. So we can use the rule where we keep the base 27 and subtract the exponent. So -1 minus -2/3. So I end up adding, and I need a common denominator, so that's going to be -3/3 is another way of writing -1. Plus 2/3, because subtracting a negative is adding, which gives me 27 to the -1/3. And then that's like, now we can say, okay, we've got a negative exponent. It's going to be 1 over 27 to the positive 1/3, which is 1 over the 3rd root of 27, which is 1 over 3. 3rd root of 27 is 3. Now you may think, okay, in H here, look, I've got the same base again, but there's no rule for subtracting powers with the same base, only multiplying and dividing. So here we have to do each of these individually. So I've got a negative exponent here, so I'm going to do 1 over 16 to the positive 1/4 minus another negative exponent, 1 over 16 to the -3/2. And then I'm going to write it in radical form. So 1 over the 4th root of 16 minus 1 over the square root of, oh sorry, this should have been a positive. So when I do 1 over, it's to the positive 3/2. So 1 over the square root of 16 cubed. So the 4th root of 16 is 2, because 2 to the 4th is 16, minus 1 over the square root of 16 is 4 cubed. 4 cubed is 64. So now I have a half minus a 64th, so I need a common denominator, which is going to be 64. So to get from 2 to 64, I had to multiply by 32, so I multiply the top by 32, and I end up with 31/64. Okay, this one's I has a mixture of fraction exponents and roots mixed together. So 81 to the 3/4, we know that that can be rewritten as the 4th root of 81 all to the 3rd, plus the 3rd root of 8 is 2, minus the 4th root of 256, so maybe I'm not sure about that. So I need, remember my thinking is some number to the 4th equals 256. So 4 to the 4th, let's try. Oh, it is 256. So minus 4. So the 4th root of 81 is 3, because 3 to the 4th is 81 cubed, plus 2 minus 4. So that's 27 plus 2 minus 4, which is 25. J looks very complicated. So let's do it a step at a time. So in the numerator, we have 4 to the 3/2, which we can write as the square root of 4 cubed, minus 8 to the 1/3, which we could write as the 3rd root of 8, over 16 to the 1/4, which we can write as the 4th root of 16 multiplied by the square root of 25. So all we did there was change all the fractional exponents to radical form. So the square root of 4 is 2 cubed, or it's 2, and then it's being cubed, minus the 3rd root of 8, which is 2. The 4th root of 16 is 2, and the square root of 25 is 5. 2 cubed is 8 minus 2 over 2 times 5 is 10. So that's going to give me 6 over 10, which reduces to 3/5. All right, so next question. Simplify and evaluate using appropriate exponent rules. So we've got root 2 times the 3rd root of 2 over 2 to the negative 1/6. So the first thing I want you to think about is all of a sudden they're giving me something that's not easy for me to figure out. I don't know the number that multiplies by itself to give me 2, square root of 2. And then if I go to my calculator, I can kind of prove that to myself. The square root of 2 is 1.4142135562. It's a irrational decimal. So if that's the case and they're asking me to figure it out, I'm hoping if it says simplify and evaluate using appropriate exponent rules, that maybe I'm going to have the same bases along the way that's going to eventually allow me to evaluate. At least I'm going to simplify first, and then hopefully I'm going to end up with something using exponent laws that will allow me to find the value of it exactly. Okay, so simplifying first, I want to put everything into fractional exponents. So we're kind of going the other way here. So for instance, if we had the square root of 3 to the 4th, we know we could write that as 3 to the, sorry, that's a bad example. I'll put a cube here. So the cube root of 3 to the 4th, we could write that exponentially as 3 to the 4/3, because we know the top number in the fractional exponent is the exponent and the bottom number is the root. So we can rewrite root 2 as 2 to the power of 1/2. And you'll see why we're doing that in a minute. And this is the 3rd root of 2. We can rewrite that as 2 to the 1/3. And then our denominator is already written with a fractional exponent, 2 to the negative 1/6. So in the numerator right now, we're multiplying powers that have the same base. And we know the rule for that is to keep the base the same too and add the exponents. So in the numerator, I have to add a 1/2 and a 1/3. So I need a common denominator for the exponents, and that's going to be 6. So, oops, common denominator of 6. So a 1/2 can be rewritten as 3/6 and a 1/3 as 2/6. So then in the numerator, I've got 2 to the 5/6, but in the denominator, I have 2 to the negative 1/6. So now we want to recognize it as a question where we're dividing powers with the same base. So that rule says we keep the base the same and subtract the exponents. So 5/6 minus negative 1/6 is 2 to the 6/6, because you end up adding when you subtract a negative, which is 2 to the 1, which is 2. So by simplifying, we were able to evaluate and get an exact answer of 2 without going to our calculator and approximating. So we'll see if that happens here as well. So 5 root 5 to the negative 2. So this 5 is, so what that really means is that 5's not in the little crook here, it's multiplying. So we have 5 times, let me write this as 5 to the 1/2 all to the -2. Okay, so there's a couple of ways we can do this. So if we do the inside first, we're multiplying powers with the same base. So we can keep the base the same and add the exponents. So if we're adding those exponents, we need a common denominator of 2, but that's still all to the -2. So that's going to give me 5 to the 3/2 to the -2. So now I have a power to an exponent, and the rule I can use there is to keep the base the same and multiply the exponents. So 3/2 times -2 is going to give me 5 to the -3. So now I can use my negative exponent rule and make that 1 over 5 cubed, which is 1 over 125. Simplify using exponent rules and then evaluate when it becomes easy enough to evaluate. And our last example then, similar again, all the same bases. So first step is going to be to rewrite everything in exponential form instead of radical form. So that's 3 to the 1/2 times 3 to the 3 over 2 over 3 squared. In the numerator, we're multiplying powers with the same base, so we're going to keep the base and add the exponents. Which is going to give me 3 to the 4 over 2. 4 over 2 happens to be 2. Something divided by itself is 1, or you could think of it as 3 to the 2 minus 2, which is 3 to the 0, which equals 1. So a complicated way of writing 1. All right, so you've just learned what a fractional exponent means. So our success criteria to understand the meaning of a rational exponent, and again, that means an exponent that's a fraction, a positive or negative fraction. I can understand the link between rational exponents and roots, and I can evaluate a numeric exponential expression that involves a rational exponent with minimal use of a calculator. All right, thanks guys.